one thing I want you to realize is with this chart, this means that these are your perfect squares. These are your perfect cubes. These are your fourths. These are your fifths. And I know it says it, but I just want to make sure you guys realize that that's what it is. So those are your perfects. All right. So when we talk about today, when I say one of the numbers have to be a perfect, it has to be in your squares. All right. This is going to help you hopefully to get this done. All right. So 7-1 continued. 7-1 has a lot of information in it. Yesterday we started it. And today we're going to finish it. So,
hold your horses.
All right, I will. So we got rules of radicals, and I'll pause it. All right, so rules of radicals. If you have an even root, meaning like the square root, the fourth root, etc. If the number above your root sign is even, you have to remember two things. The first thing you have to remember is you cannot take the even root of a negative number. We are going to learn imaginary numbers, but it's only actually with squares. But we are going to learn imaginary numbers this chapter. But right now, we cannot take an even root of a negative number. So if I had the fourth root of negative 236, if this is even and a negative's underneath the square root or of the fourth root sign, all you do is you write undefined. The second rule. So first of all, anybody that you do not understand this, you can have it on the outside. So if you had the negative on the outside, that's okay, but it cannot be underneath. So you cannot take the fourth root of a negative number. All right. The second rule is if you have variables underneath the root and you're talking even, you have to put them in the absolute value. So if have variables under the even root, must put absolute value signs around the variables when it comes out. So if you have a variable underneath an even root, you must put absolute value signs around the variable when you take it out. And I'm going to give you an example of it too. If I have my example, is going to be the fourth root of 81a to the fourth, b to the sixth. First thing you always want to check is this a perfect fourth root? So, what is the fourth root of 81? 3. Because if you guys, what you do, just so you know, you go to your fourth root, 81 is there, so it's 3. That's how you use your chart. So we have 3 is our on the outside. It says if there's variables you're taking out, you have to put an absolute value. Think about what you have to do is divide that. 4 divided by 4, 1. Is there a remainder? No. So that's going to come out. So your A is going to come out. I'm not going to close it yet because we have a B. We have B to the 6. We have to divide that by your 4. So how many B's can we take out? 6 divided by 4. 1. How many left over? 2. The thing that's left over has to stay under, oops, why did I say it's a 2? Where's my little 2, my right 4? My eraser is gone. Yeah, pencil doesn't show up very good on the when I'm taping, or for you guys to see. But I agree. So, to get the number that comes out again, what you're doing is you're dividing it. So 6 divided by 4 is 1 with 2 left over. Whatever remains stays here. Then if this is even number, you have to take the absolute value of, you have to keep in the absolute value. All right? Anybody know why we have to put the absolute value of that? Because when it comes out, it's going to be positive. And you can't have the square root as right. So, just so you know. All right. Now, these are the rules if it is even root. You're going to love odd rules. So, yes. No, well, actually, you'll love it. You really will like it. You really will like it. Odd rules. So, odd roots. You can take the odd root of anything. You don't have to worry about the absolute value. You don't have to worry about anything. So odd roots, just take the root. No, it won't be decimals, but you don't have to worry about absolute values. You don't have to worry about negatives. So you're just taking the root. You will still have to do the perfects, that stuff, but you won't have to worry about any other rule. All right, so you can on odd root, you can always take an odd root, and you can always take an odd root. It doesn't matter what it is. All right, so here we have actually 2, and then the 5th root of 100, actually negative, I'm going to do this in negative, negative 160, a to the 6, b to the 7. All right. The first thing you want to do is look at your fifths. 160 is not one of your perfects. So we have to figure out what one of these goes into 160. Yes, 32. 32 times what gives me 160? 5. So we're going to take negative 32, because we're going to take the negative out, times my 5, a to the 6, b to the 7th, just to rewrite it so you guys can see what we're going to do. All I did was take 160 and look at it, see how that 5 is there? So we have here, is 160 here? No. So you find out what number goes into 160. Well, 160 is smaller than 243, so the only possibility that would go into it is 32. If you take 160 divided by 32, what do you get? Do it in your calculator so you can understand. 160 divided by 32. 5. That's where they got that number. That's all we've done so far. Okay. So, what is the 5th root of negative 32? Look at your top. 2. Negative 2 is right. So, we have 2 times my negative 2, because it's coming out. The 5 is going to stay under, so I'm just going to keep an underline so I can remember that staying under. And you can also, maybe we'll just make it, this is the stuff that stays under so we don't forget. So we have the 5. We have a to the 6th, and we have to take out 5 of them at a time. So So how many can come out? 1. How many left over? So 6 divided by 5 is 1. So 1's coming out. How many's left over? If you have 6 and you took out 5, how many's left over? 1. That's where that is. So b to the 7th, how many are coming out? b to the 7th, we can take 1 out. And how many left over? b2. The only thing we have to, this is -4 because we have to clean it up, but I knew it's lunchtime.
I'm gonna risk